last lecture we studied about the molecular theory of surface tension. Okay, so in the last video we studied about the molecular theory of surface tension. Now today we are going to discuss about the surface energy and relation between the surface energy and surface tension. Okay, so in the last lecture we have studied about the molecular theory of surface tension. So for that we have considered one container which contains a liquid. Okay, this is the surface film. Okay, we have considered three molecules in this case. We have considered the molecule A, which is completely inside the liquid. This is the sphere of influence of molecule A. Then we have considered the molecule B, which is within the surface film, and we have considered molecule C, which is just on the surface film or on the surface of liquid. Okay, so now see here in this case what happened. Now here you observe that the molecule A is completely inside the liquid. So that's why the molecule A will experience a more cohesive force, because it is surrounded by from all sides by the water molecules. Okay, so that's why the molecule A will be experience a more cohesive force as compared to the molecule B and C. Okay, means why this molecule experience a more cohesive force? Because its whole sphere of influence lies inside the liquid. But in case of B and C, some part of their sphere of influence lies outside the liquid, some part is lies in this case some part is lies outside the liquid, and in this case half part is lies outside the liquid. That's why this molecule A experience a more cohesive force. Now see here, if you want to bring this molecule A in the surface layer or in the surface film, so for that we have to do some work, and from that it is very clear that means molecule B and molecule C, they possesses the more potential energy. As they possesses the more potential energy, and this extra energy possesses by molecule B and C, that extra energy is called as the surface energy. So that's the things we are going to study today. So surface energy means, see here what happened here when we want to bring this molecule A in the surface film. So for that purpose we have to do some work. So to do some work, from it is very clear that this molecule B and C possesses more potential energy than the molecule A. So as this molecule B and C possesses more potential energy than molecule A, so that extra energy, surface energy, we see here, surface energy means, see here, the extra energy, the extra potential energy, the extra potential energy possesses by molecules within surface film, and that extra energy is known as the surface energy. Means what happened, as we have considered here three molecules A and B and C. Okay, as A is completely inside the liquid, okay, D is just below the free surface of liquid, C is on the surface of liquid. So to bring that molecule A within the surface film, what happened, we have to do some work, and from that it is very clear that the B and C possesses the more potential energy than the molecule A. Means not only the B and C, but every molecule which is present within the surface film, they possess the more extra energy, and that extra potential energy possessed by the molecules within the surface film, that energy is known as the surface energy. Now we are going to derive the relation between surface energy and surface tension. So in the last lecture we studied about the definition of surface tension. As we know that every molecule on the free surface of liquid, it behaves like a stretch elastic membrane. Why that molecule behaves like a stretch elastic membrane? Because what happened? Because of the force surface tension, we can say. Okay? So that molecule tries to occupy minimum surface area, and that is known as the surface tension. So in the last lecture we defined the surface tension like surface tension is nothing but the force per unit length, tangential force per unit length acting on that imaginary line. So now here we are going to derive the, and surface energy means whatever be the extra energy, extra potential energy possessed by the molecules within the surface film. This extra energy is known as the surface energy. Now here we are going to derive the relation between surface energy and surface tension. So relation between surface energy and surface tension. So relation between surface energy and surface tension. So we know the definition of surface energy. We also know about the surface tension. So we are going to find here relation between these two things. So now for that, first we consider any rectangular frame. Now I am considering this is a rectangular frame PQRS. Okay. So I am considering this is the frame, rectangular frame PQRS suppose. And this arm QR, it is a movable one. That's why PQRS. Okay. So I have considered one rectangular frame having one arm QR is a movable one. This arm QR is the movable one. Now I dip this whole assembly into the soap solution. Okay. Then what happened? A soap film will be formed over this frame. Is what happened? I dip this whole assembly into the soap solution. Then what happened? The soap film will be formed over this frame. Now as the soap film will be formed over this frame, then what happened? As you know that each arm experiences a force. Now this frame has 4 arms. All these arms are fixed, but only this QR arm is the movable one. So as this QR arm is movable one, and we have dipped this whole assembly into the soap solution, that's why the soap film will be formed over this frame. As the soap film will be formed over this frame, due to that soap film, what will happen? That frame means each arm of that frame will experience a force. But all 3 arms are fixed. But only the arms QR, it is a movable one. As this arm QR is movable one, so that's why it will be moved towards this PS by force of surface tension, suppose F. So what is F here? Suppose let F be the, we can say, force acting on movable arm QR. Okay, and the length of this QR is suppose capital L. Okay. So we have considered that the force F, that is the force due to, why this force is acting? This is the force due to the surface tension. Okay. Now we know the definition of surface tension. We have the definition of surface tension. So T is equal to, what is the definition of surface tension? Force per unit length. So T equal to force per unit length. Okay. We know this definition of surface tension. Now see here, as this arm is moved towards as this QR arm, it is a movable one, and it moves towards the PS. So this much force is F is acting on that arm QR, and the length of that arm QR is L. Now therefore we get F is equal to, what we get? T into twice L. So why I write twice L here? Because what happened? This is the frame. And this frame, suppose this is the, imagine that this is the frame, and this frame has the 2 surfaces. Suppose this is the upper surface and this one is the lower surface. So that's why the force of surface tension acting on this arm QR having a length is equal to twice L. So the force of surface tension acting on this length will be considered as twice L, because this frame has a 2 surfaces. One is the upper surface and second one is the lower surface. So that's how we write this as a F is equal to T into twice L. Okay. So this is the equation number. Suppose we consider this as equation number 1. Now suppose we are imagining that, imagine that the equal force F dash. Suppose the equal force F dash is acting on opposite side of this force F. Okay. And because of this force F dash, what happened? Because of this force F dash, what happened? It will be the area of this frame will be increase. Area of the surface film will be increased because of this force F dash. Means due to the force F dash, the movable arm QR it moved to Q dash R dash through a distance dx suppose. Okay. Now in surface energy we know that what happens. Surface energy means the extra energy possessed by extra potential energy possessed by the molecule which are present within the surface film. That extra energy is known as the potential surface energy. And you know that every system try to attain the minimum potential energy. Okay, and every system try to attain the minimum potential energy. So for that purpose, what they will do? They will try to reduce the area of the surface film. Okay, and they will spend their most of the energy to increase the area of the liquid. Okay, so that's why the equal force F dash is acting opposite to this force. Okay, and because of this force, the frame QR it moved to Q dash R dash. Okay, through a distance x. So this is the F force equal and opposite to F. Okay, force of surface tension F. So what happened now? As this force is because of this force F dash, the movable arm QR it moved to Q dash R dash. Okay, as this arm is movable, moved to Q dash R dash. So due to that, some work has to be done. Okay, you know that work done is equal to suppose some work BW has to be done. So how we can find the work done? We know that work done is equal to force into displacement. Force into displacement. So how much force F dash into displacement is dx. So displacement is dx. Okay. So now see here. We know that F is equal and opposite to F. So we can put simply F into dx. Okay. So therefore dw is equal to F into dx. And from equation 1 we know the value of F. So from equation 1 F is equal to what is the value of F? T into twice L. Okay. So dw is equal to F. What is the value of F is here? T into twice L. So we will write this as T into twice L dx. So now see here, this is a rectangular frame. As because of the application of force F dash, the frame will move from QR to Q dash R dash. And during this moment that frame will travel, or suppose it cover a distance of dx. Okay, means some work is done to move that frame from one place to the another place. So that work done is equal to dw is equal to F dash into dx. Okay, that is F into dx. Now we just put the value of F from the equation 1. So dw is equal to T into twice L dx. Now our frame is a rectangular one, and we know the area of rectangle is length into breadth. So its length is capital L and its breadth is here dx. Okay. So now here instead, so we can write this T is equal to, it is nothing but the increased area of this frame. Okay. The increased area of this film. So we can write this as T into dA. Okay. So now this T into dA, this is the work done, and this work done is stored in the form of stored in the increase in area dA in the form of potential energy, and that potential energy is nothing but the surface energy. Therefore we can write surface energy is equal to T into dA. So this is the relation between surface energy and surface tension. So surface energy is equal to T into dA. So from this relation we can easily tell surface tension T is equal to suppose surface energy E upon dA. So the surface tension T is also equal to the surface energy per unit area. Okay. So this is the relation about the surface energy and surface tension. Okay. So see here once again I repeat this thing. So we are surface energy means the extra potential energy possessed by the molecules which are present in the surface film. Okay, so that energy is known as the surface energy. Now we are going to derive the relation between surface energy and surface tension. So for that purpose, what we have considered? We have considered one rectangular frame PQRS. Okay, and we dip this whole assembly into the soap solution. Then what happens? A soap film will be formed over this frame. Okay, so now you know that as the soap film will be formed, because of the surface tension, some force will be act on each arm of that frame, but all arms are fixed, but except the arms QR. As the arm QR is movable one, that's why that arm QR will be pulled towards move towards the PS with the force F. So F with the force of surface tension acting on movable arm QR. Okay, so we know the definition of surface tension. T is equal to force per unit length. But here what happens? This is the frame. Suppose that frame has two surfaces. One is the upper surface and another is the lower surface. Okay, one is the upper surface and another is the lower surface, and the force acting on that movable arm having a length, movable arm QR having a length L. So having a length is equal to twice L, because it has a upper surface as well as lower surface. Therefore F is equal to T into twice L. Okay, so that's why now we are imagining that the force F dash is equal and opposite to the force F. It is acting in this direction, and because of that force, what happens? The area of the surface film will be increased, because the QR will be moved from QR to Q dash R dash, and the area of the surface film will be increased. As area of the surface film will be increased means through the distance dx, means to move that arm QR to the Q dash R dash, some work has to be done. So that work done is nothing but the force into displacement. So because of the which force that work is done, that arm is moved, F dash force. So F dash into dx. So dw is equal to F dash, because F dash is equal to F into dx. So simply we put the value of F from the equation 1. Okay. So therefore F is equal to T into twice L dx. So dw is equal to क्या मिला हमें? So T into dA. Now this is how this dA is come here. As we know that the area of rectangle is nothing but the length into breadth, and this is the area of increase in surface frame. Okay, dA. Okay, so that's why this work done is stored in the form of potential energy, and that energy is nothing but the surface energy. So surface energy is equal to T into dA. Okay. So surface energy, the relation between surface energy and surface tension is surface energy is equal to T into dA. dA is the increase in area of this surface plane, and that work done is stored in the form of surface energy. And from that we can easily we can also test that surface tension is equal to the surface energy per unit length. Okay. So this is the, from this we can tell that surface tension is equal to surface energy per unit length. Okay.